Now what you can see on the screen is you have a graph, and this graph talks about some data of 5 years. So now my question to you is, what all you can understand from this graph? You can look at this graph and you can try to tell me what all details you can get from this graph. So what we can do is, the first thing is, first we have to define the problem statement. It is always important in any kind of analysis to define the problem statement, to define the requirements. Because I'll tell you one statement, I'll discuss this statement in more details in today's session itself and in tomorrow's session also. Problem defines population. Very important statement is, problem defines population. And if you don't know what is your population, you will end up selecting wrong sample. And if you select wrong sample, your analysis will be wrong, your conclusion will be wrong. So always remember, the first important step is to define the problem exactly. What are your requirements? So what are my requirements for next 5 years? What I want to predict? Am I going to predict the same thing, the annual global technology forecast, or something else? And my region is the global region, or I am going to restrict myself to Asian region? So all these things has to be defined first. So that is my step number one. What is the problem? Problem definition. And we'll discuss the meaning of this statement, problem defines population, in further slides. Fine. Now, once the problem is defined, once we know what is the requirement, exact requirement, then to solve that problem, whatever is the appropriate data, relative data, we have to collect that data. So we have to start collecting data points which will help us to solve that problem. So the second step is collection of data, collection of appropriate data. Once I collect the data, the next step is to analyze that collected data. Simple. If I have data, I'll start doing the analysis of that data. So I'll be using Excel kind of tools or some other tools, but I'll start analysis of that data. Once I'll end up analyzing that data, I'll complete the analysis process. Then I'll try to interpret my analysis, or I'll try to present my analysis. So either interpretation of whatever analysis you have done in a few charts or in few lines, or presentation of those results. Once interpretation and presentation is finished, then I'll try to simplify my analysis or my interpretation, maybe in 1 line or 2 lines in a simple presentation format. I'll try to summarize my analysis. I'll try to conclude something with my analysis. So these are the important steps, starting from problem definition, collection of data, analyzing that data, interpretation, presentation of that data, and then at the end, we try to simplify, summarize, or conclude with on the basis of my interpretation. So if you look at all these keywords, I can call these as keywords: collect, analyze, interpret, present, simplify, summarize, conclude. All these are keywords which are important in any kind of analysis. And my request is to remember all these keywords, because if you try to define statistics, if you try to write definition of statistics, you will find all these keywords as part of the definition. This is nothing but statistics. This is nothing but analytics. You try to do all these things means you are doing statistical analysis or data analytics. Okay. So these are important keywords. Fine. Now we'll move to the next slide. Some basic definitions. So first we'll look at the definition of population. What is population? Suppose I take example, professionals working in automobile sector. So all over the earth, in this world, every person who is working in automobile sector becomes part of my population. So the total set of measurements, population is the total set of measurements. Usually population is unknowable and must be estimated by a sample. That's why we need sample. So the next definition is sample. So but before going to that definition, I told you that the important statement is population depends on the problem which you are solving. Okay, so if my problem is to find, suppose, average salary of professionals working in automobile sector, every individual who is in automobile sector on this earth becomes part of my population. But if I change my problem definition to I want to calculate average salary of professionals working in automobile sector in India, so my population changes to only the individuals who are working in automobile sector in India, Indian region. So always the problem definition defines the population. Now, because it is not always possible to go for all the individuals which are present in population, what we do is we always go for a part of the population which is a representative of the population. We call it as a sample. So sample is a collection of objects which are a subset of the population and are taken as representative of the population. So instead of taking the whole population, we select few of the populations and we create a group of those few and we call them as sample. But while selecting those few from the population, those few should be very good representatives of the whole population. Okay. Now there are some sampling methods also. There are some sampling techniques also, using which you can try to select appropriate sample out of the population. So there are some probability based sampling methods and there are some non-probability based sampling methods that we'll try to cover on session number 3 or session number 4. But there are some techniques using which you can try to select appropriate sample which is a representative of the population. So suppose I'll add a constraint to my population definition as working in Pune, like automobile sector professionals working in Pune. So that will restrict my population or my selection to Pune area only. So in this way, maybe there are 50,000, 60,000 automobile professionals who are working in Pune. So my population will be now 50 to 60,000, or I can say that will be my sample for the global population. But still I need to take a smaller sample because I cannot go to 50, 60,000 data points and I cannot collect some information from them. We'll see that process in further slides, but we need to restrict ourselves by adding some constraints to my problem definition always. So that is a relationship between population and sample. Now each and individual of my sample, every member of my sample is my object. So all these individual members who are automobile sector professionals working in Pune, all these individuals becomes my objects. The objects are unit of study. These objects are unit of study on which variables can be measured. So all these individuals will give me some information, data points, based on which I'll do my analysis. So these are the basic definitions like population, sample, and objects. Now, what is statistics? As we have discussed, if you try to define statistics, we need to remember all those keywords. So if you go to Google and if you type definition of statistics, as statistics is a science, we don't have one single definition of statistics. There are multiple definitions given by multiple researchers. So one of the definition is statistics is science of collection, presentation, analysis, and reasonable interpretation of data. Second definition is statistics can summarize and simplify large amounts of numerical data. Third definition is using statistics, one can draw conclusions about data. So if you look at any of the definitions, you will see all the keywords or important keywords are part of these definitions. So even if you try to define these statistics and if you try to include all the keywords which we have discussed in one line, that can become a very good definition of statistics. What is important to know is statistics cannot prove anything. We cannot use statistics to prove something. If you want to prove something, we need mathematics. In calculations, we have two sciences, or we can say we have two branches of calculations. One is statistical branch of calculation and second is mathematical branch of calculations. So if you want to prove something, if you want to end up with some results kind of true, not true, or true, false, 1, 0, yes, no, then in that case, you have to go for mathematical branch of calculation. Statistics, we cannot use statistics for proving anything. Estimates are normally presented in probabilistic terms. So like, for example, we are 95% sure. When I say 95% sure, I'm giving 95% chance of success. I'm still keeping a 5% chance for failure also. So we cannot be 100% sure in statistics. If I'm 100% sure, that means you are going to mathematical branch of calculation. So suppose if I say if there is a match between India and Australia tomorrow, and if I say I'm 95% sure that India may win in tomorrow's match against Australia. When I say 95% sure, that means out of 100, 95 times India may win this match, but there is still 5% chance that even Australia may win this match based on certain conditions, pitch conditions, player forms, we don't know, but there is still a possibility of 5% that India may lose the match also. So I'm keeping higher percentage for success, but there is still a possibility of failure, which may be very lower, in this case 5%, but there is a chance of failure always. So this kind of things we can do in statistics, and these are called as estimates. We can do estimates in probabilistic terms. 95% is a probability kind of thing. So statistics cannot be used to prove anything. We can do estimates in probabilistic terms in statistics always. Just for your knowledge, even if you go to Google, you will find two different words. Statistic is a word and statistics is a word. When I say statistic without S, that means a value or a parameter which describes data or the analysis. So, for example, like we calculate mean. Now we all of us have calculated average so many times from standard 1 to calculate average marks of the complete year. So that one number, that average, we call that as mean in statistics. That one number is sufficient to represent a lot of other numbers. Suppose you have marks scored in 10 subjects. Instead of me telling all those 10 numbers to somebody, I can just tell my one number, which is average of those 10 numbers, to understand the behavior of the actual 10 numbers. So that mean is a representative of those 10 numbers, I can say. So that mean is a characteristic of those 10 number, I can say. Or that mean is a statistic of my data values. Like median is a statistic of my data values. Mode, range, SD, T value, F value, Z score, F score. There are a lot of things which try to represent lot of numbers which are in the backend, which are the parameters. So we call them as statistic. So one data set can have multiple statistics. And the second word is statistics with S, which is a science. Statistics is a science of collecting, analyzing, and presenting the data. So whenever, if I say statistics is, that means I'm talking about statistics as a science. And if I say statistics are, that means I'm talking about multiple parameters which are representing that data set. Okay, so even if you go to Google and type plural of statistics, you will get this information. The word statistics is used both as singular and plural. The singular statistics is science of collection, presentation, analysis, and interpretation of numerical data. And the plural statistics refers to the numerical facts or observations collected with a definite purpose. So these are the two words, statistic and statistics. Now, why we need statistics? Why we need statistics? Very important question. If you can answer this question, then a lot of things are already clear to you in terms of analytics. And in that, I'll take the example of the same thing. Suppose I want to calculate average salary of automobile professionals. And I told you that one important statement to remember, the problem statement defines the population. Okay. So my problem statement is I want to find average salary. Fine. Of automobile professionals. So each and every individual on this earth who is automobile professional is a probable participant for my analysis. So what I'll do is, instead of taking a lot of the huge population, I'll add a constraint to my question, working in Pune. So that will restrict selection of my data points from only Pune region. Even Pune region, we have a lot of companies and a lot of employees which are working in automobile sector. So what I'll do is I'll add another constraint, working in Chakan area, which is a specific area in Pune region where all the automobile industries and a lot of other industries are present. So my problem definition becomes, I want to calculate average salary of automobile professionals working in Pune and in Chakan area specifically. So maybe there are 50,000. Suppose we consider there are 50,000 automobile professionals who are working in Pune in Chakan area. So I want to calculate the average salary of these 50,000 automobile professionals. Okay, now I have understood the problem. Now, is it possible for me to go and collect data, information from 50,000 individuals? I cannot just go and ask, just tell me your salary. No, I have to first introduce myself. I have to introduce the topic of research. I have to introduce why I'm asking this question to that person. And then I have to ask the name, designation, company, some basic information. And then maybe slowly I can ask, what is your salary range? It is 0 to 50,000, 50,000 to 1 lakh, 1 lakh to 1.5 lakh, something like that. Some ranges I'll define. So it will take at least 5 minutes. It will take at least 5 minutes to collect one observation from one object, some data points from one object. Likewise, if I have 50,000 automobile professionals in Chakan area, considering 5 minutes per observation, can you tell me total amount of time which is required to collect all the data points? 50,000 into 5 minutes. Total number of minutes, convert them into number of hours, convert them into number of days. Considering 5 days a week, number of weeks, number of months. Can you tell me how many months will be required just to collect the data from 50,000 individuals? At least 1 year? Yes?
Yes, sir.
At least 1 year, considering all the holidays and everything, at least 1 year. 1 year is a huge span just to collect the data points. If you are going to spend 1 year of time, by the time you will end collecting all the data points, the first person who has given you the observations on day one may have changed the job, may have got the increment or something like that, and the salary value of that person has changed. So 1 year span is a huge span. That too, considering I am going only for a specific area in Pune location, Chakan area. So it may not be always possible to go and collect data points from all the members which are part of my population. So what we generally do is we collect a sample, or we create a sample out of the population. So what we want to know about is population, automobile professionals working in Chakan area. So the question is it possible to collect population data? Answer may be yes. If you have enough money and enough time, you have to create, suppose, a team of 20 people just to collect the data, and those 20 people will run around for next 15-20 days. Yes, it is possible, but then you have to pay to those 20 members on daily basis, and that much of time is required. So if you have that much amount of time and money, yes, you can go to population and you can collect the data also. But generally, we don't have sufficient time and sufficient money. So what we do is we do some random selection using some sampling method, some tools, some logic. We'll select a few from the population. I call them as sample, which is a representative of population. Now, when I say representative, there are multiple meanings to this line, like representative of population. Suppose if I say that in my population there are 50% male candidates and 50% female candidates. Even in my sample, I should have 50% male and 50% female. In my population, suppose there are 75% candidates who have done post-graduation and 25% who have done only graduation. Even in my sample, I should have the same kind of combination. So there are multiple meanings when I say a sample should be a correct representative of the population. So all these things we'll cover in sampling methods when we'll cover sampling methods. Fine. So what we want to know about is population. What we have to work with is sample, which are a few selected from the population itself. Fine. Suppose out of 50,000, I'll take a sample of 500. So it is possible for me to go and collect data from 500 objects, and that I can complete in a month's time. That is okay. Now, after collecting data from 500 working professionals, which are part of my sample, suppose if I come to know that the average salary of the sample objects is 80,000. Now, when I say average salary of sample, we have to remember there are different notations for population and there are different notations for sample. So generally, the Greek letters, the Greek characters, mu, rho, sigma, these are used for population, and English alphabets are generally used for sample. So mu is mean or average of population, and X bar is average of sample. So after completing the data collection from 500 objects which are part of my sample, if I come to know like the average of my sample is 80,000, my value of X bar is 80,000, 80K. Now, considering this, I'm going to make one statement. You have to tell me whether that statement is correct or not. If it is correct, why? If it is not correct, why? The average salary of automobile professionals working in Chakan, Pune is 80,000. The average salary of automobile professionals working in Chakan Pune is 80,000. Is my statement correct or not? And why? Yes, anyone? Average salary of automobile professionals working in Chakan Pune is 80,000. Am I correct or not?
I think we don't know at what level you are considering this salary. So we are not having sufficient data. Let's say you might have considered the top management, you might have taken the middle management. We don't know which category you are talking about. So with 80K, if you are saying 80K, it is not sufficient to conclude anything about the average salary.
I'm saying my sample is correct representative of population. So like if there are 10% employees who are in upper management, 20% employees who are in higher management, 10% in middle management, 20% in lower management, and 20% who are freshers just joined. I'm keeping the same proportion in my sample also.
Yeah, then it is true. Then it is correct if you are having a similar proposal. So we can the estimation, we can say this is the estimation of the population.
Okay, anyone else? Anyone else? Can I say that the average salary of automobile professionals working in Chakan Pune is 80,000?
Sir, I would say this has no time bound. So,
This has?
this is not time bound.
Okay.
So
What do you
maybe
mean
we
by
can
that?
say the salary of the professionals is 80,000 for so and so year. Then that would make sense about the specific time frame we are talking about.
So I'm telling that average salary of automobile professionals working in Chakan Pune and the analysis which was done in May 2020 is 80,000. You can add that time constraint also, no issues. But is my statement correct? Anyone else?
I think yes.
Okay. Yes, madam, now you are audible. Okay, so a lot of reactions are coming out like, yes, we can say that. Fine. So when I say average salary of automobile professionals working in Chakan Pune, when I know that the actual number of observations, the size of the population is 50,000. We said that there are 50,000 professionals, out of which I have selected only 500. And this 80,000, which is the average, is of these 500 members who are part of my sample. In reality, if I go ahead with a team of 20 members to collect data, and if I try to collect actual data from all 50,000 participants who are part of my population, and then if I calculate the average salary, maybe my average salary will be 79,580 or 81,000. It will be very close to my average salary of the sample. But it may not be exactly same as 80,000. There will be some deviation. There will be some deviation of average salary. So what I can say is this is my actual average, and what I'm calculating is sample average. So based on sample study, if I'm trying to create some relationship for population, based on sample study, if I'm trying to create some relationship about my population, we need some statistical tools. We need some educated guess to do or to conclude something about population based on sample study. What we have is sample, and 80,000 is the answer of the average of the sample. May not be true for population. There may be a small deviation. So how can I represent that deviation in terms of population? So when I say that sample average is 80,000, I can say I am 99% sure that the population average will also be 80,000. So now I am taking the probabilistic term in the picture, 99%. Sample average is 80,000, and I can say I am 99% sure that my population average will also be 80,000. When I say 99% sure, I'm still keeping 1% chance that there may be some deviation from 80,000, and that deviation will be very less. But if I say I'm only 60% sure that even the population average will be 80,000, that means my confidence in my sample study is very less. My confidence in my sample study is very less, only 60%. So there is a 40% chance next time if I take another set of 500 candidates from the same population, my average may come completely different from 80,000. But when I say 99% sure that the population average will also be very much close to 80,000, at any point of time, if I collect any sample, my average will be around 80,000, very close to 80,000. So why we need statistics, the important part is we always deal with sample data. We always deal with sample data, and based on sample analysis, we have to do some conclusion about the population. So you have to infer based on sample analysis about the population. And to create that inference about the population, we need statistics. So you need to create some inference or educated guess about the population based on sample study. And statistics is required to make this inference for the population based on sample study. So that is the main reason why we need statistical analysis, to infer something about the population. Because population data is not available with us, sample data is available with us, but we have to conclude about population to take some decisions about the populations. If I want to implement some policy on some population, on some part of the population, I have to do some sample study, and based on my analysis, I will take the decision. So in decision making, we have to infer about population based on our sample analysis. And that's why statistical analysis is very important, to create that inference, educated guess, a bridge between sample data, sample analysis, and population analysis. So that is the answer to why we need statistics. And always remember, whenever we'll discuss something in next 5 days also, we are always concerned with this difference only. What is the actual value and what is the expected value? So we are always concerned with the difference or the deviation. The word deviation means difference in statistics. The deviation between the actual value and expected value. We may have some expected value as per that what we have discussed is from data, I have some trend of the data, and based on that trend, then I'm trying to predict something about the future. So I'm trying to predict means that is my expected value. Based on the current trend, I'm trying to predict something that is my expected value. What will be my actual value and what will be the deviation? If the deviation is very small, then my prediction is good. If the deviation is large or huge, then my prediction is wrong. So you cannot have the exact value for predictions. You will always have some deviations, and these deviations are important part of analysis. You take it regression, you take it any kind of other t-statistics, statistics for hypothesis testing, everything, everywhere you are always dealing with these deviations, and these deviations are very important. And based on this only, we have a concept called a standard deviation, which is the base concept of statistics analysis. And this standard deviation is very important concept, which we are going to discuss in tomorrow's session. Fine, so we'll go to the next slide now. And for few of them, as I have mentioned, standard deviation, all of you must have heard Six Sigma, which is a very well-known quality control framework. Six Sigma, that sigma stands for standard deviation only. That sigma is a Greek letter for standard deviation. And when I draw a standard deviation curve, we have 3 standard deviation on the left-hand side of the mean and 3 standard deviation on the right-hand side of the mean. That covers the 6 standard deviation, that is 6 sigma. And that is the base concept of 6 sigma also. So there are multiple applications which are outside statistics based on these statistical concepts. Okay, fine. So we'll discuss all these things as and when we'll come across all these concepts. So we'll go to the next slide now. So in statistical analysis, we have 2 branches or 2 types of statistical analysis. One is descriptive statistics and second is inferential statistics. So descriptive statistics, as the name suggests, when we use statistical analysis to describe something, to describe my data, to summarize my data, like mean, median, mode, are trying to describe behavior of my data. So that comes under descriptive statistics. And as we have discussed, when based on sample study, if we are trying to create some inference about population, all these kind of methods comes under inferential statistics. So inferential statistics is used to try to infer from the sample data about the population. So these two methods we have, these two branches we have inside statistics: descriptive statistics and inferential statistics. Even for inferential statistics, we have to always start with descriptive statistics, because we have to first calculate mean, median, mode, standard deviation, variance, skewness, kurtosis, lot of other things, and then only we can go for inferential statistics. So the first step is always descriptive, and then second step is, if you want to go ahead with predictions and everything or data modeling, you can go for inferential statistics. Okay, so now we have answered two questions: what and why. Now the third question is how to do statistics or how to do analysis. So as we have discussed, first thing is we need to have the question in place. So which teams have qualified for playoffs in IPL? Yes, if this is my question, I need to have the IPL points table with me so that I can go for qualification of few teams. So the data which is required to solve this problem is required. So the first and most important thing is collect required data, which will solve the problem. Once I have the data, then I have to have some rules. Only data is not sufficient. If I have to answer the question which teams have qualified for the playoffs, I need to ask the question, what is the rule for selection? So rule says the first top team, 4 top teams as per the points table. So the first 4 top teams as per the points table are these. So I can say that these 4 teams have qualified. So what is important is we need a rule for selection, top 4 teams according to the final points table. Now, luckily, we have a clear indication that these 4 teams have qualified. Now, consider, suppose even the 5th team has the score 16, points as 16 instead of 14. Now, in case of top 4 teams, this team is already selected. There is no doubt in that case. But now we have 4 teams with same score, and I have to select only 3 out of them. So I need to have rules properly defined for clear selection. Like if points are same, then we will go for net run rate, NRR, the second column. If NRR is also same, then maybe we'll go for number of wins, something like that. So the rules have to be specifically defined, which will select the top 4 teams, which will solve my query. So that is my next step, that you have to apply the available set of rules on the available data to answer the question. And this is the method, or this is the answer to how to do statistics. First step is problem definition, requirements, specifying the requirements. Second is collecting appropriate data, which is also called as data collection or sample collection. Based on data collection, whatever data you have, then data analysis, organize, summarize, apply the conditions on the available data, and conclude, come to the conclusion, present the data, results, data visualization. So this is the simple 4-step method for how to do analysis. Now in this case, data collection, you can see 4 different methods which can be used for data collection. First is observation method, second is interview method, third is questionnaire method, and fourth is database method. Now when I say in questionnaire method, what is the meaning of questionnaire method? Questionnaire method means whatever questions I want to ask to any object, I'll mention all those questions on a paper with possible answers, and then I'll distribute those questions to a large number of objects. So whenever we have to collect data from, say, 100 employees or 200 employees, 500 objects in one shot, we can go for questionnaire method. But in case of questionnaire method, the types of questions should be well defined, and even the possible answers should be well defined for all these questions. So in case of a structured manner, I can say in case of a structured manner, if you want to collect data points, you can go for questionnaire method. But multiple times, whatever question you are trying to ask, you may get subjective answers or descriptive answers. In such cases, there is no use of questionnaire method, because again, you have to understand from the description of answer that what kind of data, is it a positive, negative, some kind of data, you have to understand from that description again. So in such cases, we can go for interview method. When we have a small amount of objects to collect data from, we can go for interview method, where we can go face to face, we can ask the questions, we can listen to the answers, and we can note down the data points from those answers. Next method is database method. Database method means I will go for the past records, existing records, last 3 years financial statements, profit and loss accounts, or something like that. Maybe employee feedback of last 3 years. All these things comes under database method. That means I'm going to understand something from the existing data. And last is observation method. Observation method means you will just go and sit in that office, or you will try to work as one of the employees in that office, and you'll keep observing the things, how the things are moving, how much time is taken to move the file from one table to another table, then who is reporting whom, and all these things. Maybe on paper the organization structure is different, and in reality the reporting structure is different. So all these things you can come to know from observation method. So these are the 4 important data collection methods: observation, interview, questionnaire, and database. As per the requirement, you can select one or multiple, combination of multiple data collection methods to collect the data. So this is all about data collection. Like you can go for a combination of interview and questionnaire. Like if there are 500 employees in one company, maybe you can go for interview method for all the CXOs like CTO, CEO, CMO, and all these things. And for other employees, you can go for questionnaire method. So likewise, you can select one or multiple combinations of the data collection methods. So this is answer to how to do statistics or how to do analysis. So this is a 4-step approach: query, define the query, collect the data, analyze the data, and represent the analysis. And as we have discussed, in case of data analysis, we have 2 branches of calculations: statistics, which is a probabilistic branch, and mathematics, which is a deterministic branch of calculation. So in statistics, it helps us in finding patterns in data from observed values. We can estimate probability of the conclusion. In mathematics, we cannot estimate, but we have to prove the statement. We can find possible, not possible, true, false, 1, 0 kind of conclusions using analysis. Fine. So this is all about the basic definitions of which are required to start with this course, and the answers to the basic questions like what is statistics, why we need statistics, and how to do statistics. So now the next segment is measurement scales. When I say measurement scales are nothing but the data types. Different data types. There are 4 different data types which can be used in any kind of analysis: nominal, ordinal, interval, and ratio. So now we'll discuss these measurement scales. Out of these, nominal and ordinal measurement scales are based on counting principle, and interval and ratio scale are based on measurement principle. So again, I want to open this for discussion. Try to tell me what is the meaning of counting and what is the meaning of measurement, and what is the difference. Counting and measurement. When I say, suppose if I tell you one statement like, I drink coffee every day. I drink coffee every day. That means I like coffee, so I drink coffee every day. But there is nothing I can get something which is in numerical format from this statement. So it is a plain qualitative statement, I can say. It talks about quality. It talks about my liking. So I drink coffee every day. Fine. The next statement is, I drink 2 cups of coffee every day. I drink 2 cups of coffee every day. So this statement tells me that I like coffee, and how many cups I usually drink is 2 cups of coffee. So I'm trying to count number of cups that I'm drinking. I'm drinking 2 cups of coffee every day. Fine. The third statement, if I say I consume 40 grams of sugar with each cup of coffee. I consume 40 grams of sugar with each cup of coffee. So when I say I consume 40 grams of sugar, I have to measure how much of sugar. I cannot count the sugar particles. I have to measure the amount of sugar which I am consuming. Like what Japan sir has said. How many participants are there in a class? I can have 8, 9, 10, 15. I cannot say I have 8.5 participants in my class. No. So counting will always result in whole numbers. Counting will always result in whole numbers. 2 cups of coffee. measurement will always result in fractional numbers. Measurement will always result in fractional numbers. So height, age, or even the amount of sugar, all these are measurements. Time is, we can measure the time, we cannot count the time. It can be in hours, minutes, seconds, fraction of seconds, it can go beyond that also. So basically counting is discrete in nature and measurement is continuous in nature. When I say counting results in whole number, that means counting is discrete in nature. And when I say measurement results in fractional numbers, measurement is continuous in nature. Okay, so we'll discuss all these things again on a few of the slides in this session itself. So nominal and ordinal, these data types, measurement scales, are based on counting principle. That means we can only count. If the data type is nominal or ordinal, we can only count. We cannot do anything else. But when I say measurement principle, like interval and ratio are based on measurement principle, we can add, subtract, we can multiply, we can divide, we can do a lot of other things also. So mathematical operations are possible with measurement data types, and only counting is possible in case of nominal and ordinal. Okay, fine. So now we'll start with the measurement scales. So before that, just for your knowledge, this scheme like nominal, ordinal, interval and ratio, this scheme was developed by Stevens and it was published in 1946. So from 1946 in different types of analysis, we have started using nominal scale, ordinal scale, interval scale and ratio scale. Okay, fine. So first is nominal. What is the meaning of nominal? Values without any inherent order or ranking or sequence. Nominal scales are used for labeling variables without any quantitative value. Norm in French is name or just a label. So I'll explain you this with the help of example. Just look at the first example. What is your gender? My question is, what is your gender? My answers are male and female. But because male as answer is present at first location, that doesn't mean males are superior to females. No. Or male are more important than female. No. Even if I write male as second option, doesn't matter. If my gender is male, I'll select male. If my gender is female, I'll select female. So values without any inherent order or ranking or sequence. That is nominal. So male is just a label. Female is just a label. There is no importance to the order. There is no importance to the rank or the sequence. Look at the second question. What is your hair color? Brown, black, blonde, gray, other. If my hair color is black, I'll select black. That doesn't mean brown hair person is superior to black hair person. No. There is no inherent order, ranking or sequence. Brown, black, blonde, these are just labels. Whatever is my hair color, I'll select that label. So this is called as nominal. And if I asked this question, suppose what is your gender? If I'm trying to ask this question to 50 individuals, what max I can do is out of 50, how many have said male and how many have said female? I can count. That's why I said that nominal and ordinal are present on based on counting principle. I can just count how many male, how many female, how many brown, how many black and so on. So this is nominal type of data or nominal scale. So that's why it is written nominal scales are used for labeling variables without any quantitative value. There is no quantitative significance. There is no value significance in terms of numbers. All these scales are mutually exclusive. There is no overlap and none of them have numerical significance. And there is a subtype of nominal scale with only two categories like male and female, the first question, which are called as dichotomous. When we have only two categories possible, male and female. In that case, it is a dichotomous nominal scale. And others are non-dichotomous nominal scale. So in case of nominal scale also, we have a special type of nominal scale with only two possible options available or two possible categories available. That is called as a dichotomous nominal scale. Okay, so that is all about nominal scale. Very simple data type, just to represent labels and nothing else. Now the next data type is ordinal. With ordinal scales, it is the order of the value which is very important and significant, but the difference between each one of them is not really known. Ordinal scales are typically measures of non-numeric concepts like satisfaction level, happiness level, discomfort level, pain level, and all these things. Okay, so I'll explain this with the help of example again. Look at the first example. My question is, how do you feel today? How do you feel today? And my possible answers are very unhappy, unhappy, okay, happy, very happy. Now you can see there is some order in my answers. I'm going from negative to positive. There is some order, there is some sequence. If my first option is very unhappy, then my last option has to be very happy. Extreme negative and extreme positive. I cannot give options like very unhappy and second option very happy, third option unhappy, fourth option okay, last option unhappy. No, I cannot do that. If I'm starting from very unhappy, I have to go decreasing my level of how I feel today, like very unhappy, then I have to go for unhappy, then okay, then happy, and then very happy, from negative to positive. So there is some order, there is some sequence, there is some logic in my answers, and that order is important. So with ordinal scales, it is the order of the values which is important and significant. That is ordinal scale. You can say ordinal scale or ordinal as ordered nominal. Ordered nominal. So still these are labels, but the labels are in ordered fashion. In some logic, there is some logic in that order. Now look at the second question. How satisfied are you with our service? If my first answer is very unsatisfied, which is negative, my last option has to be very satisfied, which will be positive. So I'm going from negative to positive. So there is some order. That is ordinal variable. But still, order is there, but I don't know the difference. Rather, all the answers are subjective. Like for example, in some situation, if I go back to my first question, how do you feel today? In some situation, if my understanding of that situation, I think I feel very unhappy about the situation. Like Corona, like now we are facing Corona COVID-19 problem. So my feeling is I'm very unhappy with the situation, whatever is going on. Compared to that, if you ask this question to a drug manufacturer, not from the emotion perspective, but from business perspective, that drug manufacturer will say, I'm very happy with the situation because that drug manufacturer can see some business going ahead. So same situation for different persons, the same situation, one person can be happy, one person can be very unhappy or very happy. The answers can be different. These are subjective. It's based on perception. How I react to that situation, it is based on that perception. And when I say very unhappy and when I say unhappy, I don't know the difference. What is the meaning of very unhappy and what is the meaning of unhappy? For me, whatever is unhappy, for someone else, that may be very unhappy. So likewise, I cannot quantify. In short, I cannot quantify the meaning of very unhappy and unhappy because I cannot know the difference between them. And that is the second thing. But the difference between each one is not really known. I just know very unhappy is different, unhappy is different, but I don't know at what point I can say that from very unhappy I have shifted to unhappy. That is subjective. Okay. So in above case, we know that number 4 is better than number 3 or number 2, but we don't know and cannot quantify how much better it is. Difference between okay and unhappy may be or may not be same as difference between very happy and happy. So that is all about ordinal scale. Both nominal and ordinal, both are based on counting principle. Again, in this case, for this question, if I'm asking this question to 50 individuals, what I can do is I can just count out of 50, how many have said very unhappy, how many have said unhappy, how many have said okay, and so on. I can just count. So nominal and ordinal are based on counting principle. We cannot do any mathematical operation because quantity is not present. Nominal and ordinal both are talking about quality of information, actual information. I cannot quantify them, so I cannot do any mathematical operations also. Okay, so now we'll go ahead. Next is interval data type, interval scale. Interval scales are numeric scales in which we know not only the order, but also the exact difference between the values. So we are going one step ahead. In nominal, it was just labels. In ordinal, now labels have the order. In interval, now we know the difference also. We are going one step ahead. We know the difference also. When I say we know the difference, that means we can do addition, we can do addition and subtraction. With interval data types, we can do addition and subtraction also. Okay. In case of Celsius temperature, now we'll take the example of temperature. Celsius temperature, the difference between 60 and 50 is measurable. I can count, I can measure. If the temperature of Pune and temperature of Mumbai, then I can measure the difference in the temperature in Pune and Mumbai. Yes, that is measurable. It is 10 degrees. In case of 60 and 50, the difference is 10 degrees. So the difference between the values is measurable, but also the exact difference between the values is measurable. Okay, so we are going one step ahead. Interval itself means space in between. When I say interval, the dictionary meaning of interval itself is space in between, which is the important thing to remember. Interval scales tells us about order and the values in between also. Okay, fine. Now the problem with interval scale is they don't have a true zero. So I'll explain the meaning of true zero. But just to give the hint of what is the meaning of true zero, there is no such thing as no temperature. There is no such thing as no temperature. Even if I say zero, the temperature is zero, even that zero temperature has some meaning. It is present. Even that 0 degrees Celsius is present in the environment. So zero means nothing is not the true. So no true zero. I'll explain the concept in further slides about the true zero. But in case of intervals, interval data types don't have a true zero or absolute zero, a defined zero. Okay, fine. If we have a true zero, then we can easily compute the ratios. Okay. With interval data, we can add, subtract, but cannot multiply and divide because we don't have a true zero. So this is all about interval. First, we'll look at ratio, then we'll look at the meaning of true zero. So we'll come to know about the last three statements. Ratio. Ratio scales tells us about, now you can see the definition, order. They tells us exact value between them, that is difference, and they also have an absolute zero. So everything is there in case of ratio. We have the order, we have the difference, and we have the absolute zero, because of which we can do multiplication and division also. So which allows us for a wide range of both descriptive and inferential statistics to be applied. These variables can be meaningfully added, subtracted, multiplied, and divided. Okay, look at this example. Oil prices in USD figures. Just read this example and tell me what you have understood from this example. Yes, anyone?
It is a measurable quantity.
Okay.
And based on the numbers, I mean, we can conclude to some definite conclusion.
Okay. Okay. So what is important in this example is even that zero is defined. When I say $0, that zero is defined. So the space in between, or the difference between 1 and 2 is same as difference between 99 and 100. And when I say that's why the cost of one barrel is 100, the cost of two barrels has to be 200. It has to be 2 into X. Okay, what 2 into cost of one barrel. So this is one example to describe the meaning of ratio. Now I'll go into more details about what is ratio, what is interval, and what is true zero. Okay. What is the meaning of true zero or absolute zero, non-arbitrary zero? I'll take two examples. I'll take example of height of buildings. I have two buildings, building A and building B. height of building A is 300 meters and height of building B is 600 meters. Fine. And then I'm taking second example, which we have discussed for interval scale, which is temperature. So temperature of city 1 is 20 degrees centigrade and temperature of city 2 is 40 degrees centigrade. Okay. So I'm now going to compare these two examples, height and temperature. I'm telling you the answer upfront. Height is ratio scale and temperature is interval scale. So height is ratio and temperature is interval. Why? Because as we have discussed, height has a true zero. What is the meaning of that? If I change the measurement scale, if I change the unit of measurement from meter to centimeter, 300 meters becomes 30,000 centimeter, 600 meter becomes 60,000 centimeter. But still with meter I can say the height of B is twice as height of A. Even in centimeters I can say the same statement, height of B is twice the height of building A. Why? Because even if I change unit of measurement, 0 meter 0 and 0 centimeter are same. The meaning of 0 is same for meters as the meaning of 0 in centimeters. That means height as a variable has a defined 0. 0 is 0. You can take any scale, 0 is 0. But look at the second example. If I change degree centigrade to degree Fahrenheit, that 20 becomes 68 and 40 becomes 104. With only degree centigrade, if I'm making a statement that the temperature of city 2 is twice hot as degree temperature of city 1, that statement is not true in case of degree Fahrenheit. Because 0 degree centigrade and 0 degree Fahrenheit are different. Temperature as a variable don't have a defined 0. 0 has different meanings in different units. 0 has different meanings in different units. So that is the meaning of true 0. That is the meaning of absolute 0, or that is the meaning of non-arbitrary 0. So when for a variable we don't have a true 0, those are interval variables. And for variables we have a true 0, those are ratio variables always. So 0 is defined, that is a ratio variable, and 0 is not defined, that is interval variable. Okay, so that is the difference between the interval and ratio, basic difference between interval and ratio. Now if you want to summarize all the measurement scales, this one table is sufficient to summarize all the measurement scales. If you just remember this table, that is sufficient. So order of values is known. Order of values is not known in nominal. It is known in ordinal, interval and ratio. Yes. Okay. Now counts, that means we can count, or frequency distribution can be implemented. Yes, counting is possible for all. Even if interval and ratio are based on measurement principle, but still we can count and measure also. Mean, median, mode we'll discuss in tomorrow's session, but in case of interval and ratio, we can calculate everything. Mean, median, mode, all central tendencies can be calculated for interval and ratio. As we can calculate central tendencies, mean, median, mode, we can also calculate standard deviation and variance and everything else. But in case of nominal, only mode is possible. Median and mean is not possible. And in case of ordinal, mode and median is possible. So we'll discuss all these things in tomorrow's session. Can quantify the difference. That means addition, subtraction is possible. Yes, it is possible only for interval and ratio. Multiplication and division, only ratio. Has a true 0, only ratio. Okay. So this one table is sufficient. If you remember this one table, you have understood all the measurement scales clearly. Yes. So can you go? Can we go ahead? Yes, all of you. Everybody can come out of the mute and can answer yes and no. If you have any doubts, you can ask the questions now. Yes, Namrata. Yes, Chaitali, Namrata, please speak. Can we go ahead? Have you
Yes, sir.
Okay, Chaitali, thank you.
Yes, sir.
Okay, Chaitali, thank you. Namrata, Aniket. Yes, thank you, Jopan sir. Aniket, Chandrakant, Varsha.
Yes, sir, we can proceed further.
Okay, fine, Aniket, thank you.
Yes, sir. We can go.
Okay, fine. Okay, great. Now, considering that all of you have understood the measurement scales and basic definitions are clear to you, I am giving you one activity. You have to classify all these variables into nominal, ordinal, interval, and ratio, N, O, I, and R. I give you, say, 2 to 3 minutes. That is sufficient. So in next 3 minutes, try to classify them, and then we'll discuss the answers also. Okay. So I give you 3 minutes for this assignment. Yes. So are you ready with the answers?
Yes, sir.
Okay. So maybe one by one you can give the answers. Religion. Yes. Anyone? Religion?
Nominal.
Nominal. Okay. Very good, Chaitali. Thank you. Temperature. We have discussed temperature. So I'll skip this temperature. It is interval. IQ. IQ.
Ordinal.
Ordinal. Okay. Why ordinal?
Interval.
Otherwise, why ordinal?
IQ is interval.
Interval, sir.
Okay. Advait, why it is ordinal?
Sir, no, it's interval.
Sir, interval.
Why interval?
Sir, because it have a, it is having an order.
Okay. Okay. Why interval? Yeah, madam.
Interval, we can measure it. IQ.
Okay. Anyone else? Why IQ is interval?
Sir, it is having order and difference as well. Difference matters.
Correct. So it is interval. Okay. Fine. So religion is nominal, temperature is interval, IQ is interval. Very good. Age.
Age is
Sir, interval again, I think.
no, ordinal. Age is nominal.
Age is
Ratio, sir. Ratio, sir.
Age is ratio.
Yes.
We can multiply, divide also. Age. Addition, subtraction is possible. Multiplication, division is possible. Age is ratio. Because age has a defined zero. From date of birth, you can calculate number of dates. That will remain fixed. So that starting point is 0. Fine. So I'll first take the DOB, date of birth. As we have discussed date of birth while discussing age. What is date of birth?
Ordinal.
Okay. Anyone else? DOB?
Ordinal.
No.
It is nominal.
Nominal.
It is interval.
Interval.
Any kind of date. Always remember, any kind of date is always interval. Any kind of date is always interval because they don't have a defined zero. They don't have a defined zero. Why I say they don't have a defined zero? Because the starting point or the 0 point for different calendars is different. English calendar is having a different starting point. Marathi calendar is having a different starting point. Hindi calendar is having a different starting point. Maya calendar is having a different starting point. So all these calendars have different zero starting points. So they don't have a defined zero. That's why it is interval. Because the difference can be calculated, but they don't have a defined zero. So that's why it is a interval. But in case of age,
Joke, sir, I am having one doubt here. Let's say date of birth we are writing in English. That means it goes with the English calendar. If we are writing in Marathi or in the other language, then we can say it is not having the defined zero. That is what my assumption about date of birth.
Correct. So that's why date of birth, because in all our official records we use only one calendar as base. That's why you are telling me like that. But DOB as a variable, As a variable,
Okay.
the correct answer is it is interval. But because now we are only using one English calendar as the base calendar, you can count it in ratio also. But as a variable, the type of DOB is interval. And that's why you will also see a lot of analysis methods and tools. Date by default is defined as interval, as data type.
Okay. Okay.
Okay.
Good.
But in case of age, though age is based on some date only, because number of days you can calculate from your date of birth until the date of today, that difference will remain same in number of days, because you go to every calendar, one day is equal to 24 hours. That is fixed, that is constant across calendars. So age becomes a
Right.
ratio, but DOB or any date becomes interval.
Right. Got it, sir. Thank
Okay.
you.
Okay. Next is satisfaction level.
Ordinal.
Yes, so we have discussed this, any kind of level, happiness level, satisfaction level, understanding level, pain level, all these are ordinal, correct. Height, we have discussed, it is a ratio, so I'll skip that. CGPA.
Interval, sir. Interval.
Why interval?
Ratio, sir.
Because we can, no, we can, just wait.
Yes, Chetali, please explain.
Sir, CGP is, yes.
Yeah, Mansi madam, yes, please.
So, sir, we can count the exact difference between the value in CGPA. So,
Okay. So CGPA is interval, correct? Why CGPA is interval? Answer is correct actually. CGPA is interval because they don't have a defined zero. Again, I'm telling you that this defined zero concept is very important in ratios. Why CGPAs don't have defined zero? Because every university follows different CGPA pattern. Every some university follow 4-point CGPA, some university follow 10-point CGPA, some university follow 8-point CGPA. So if my CGPA is 3.5, that 3.5 has different meaning is different CGPA patterns. Okay, so that CGPA is interval. Okay, gender we have discussed, it is nominal, so I'll skip that. Exam grade and class rank. Exam grade and class rank, both are ordinal. Grade and rank, as the name itself suggests, grade has to be in ordinal, rank has to be in ordinal. So exam grade and class rank are ordinal. Then income. Next is income. Anyone?
ratio, sir, ratio.
Yes. So any currency, any
Ratio, yeah.
related to currency is always a ratio. Be it income, expense, anything, it is always a ratio. Diet type. Diet type has to be nominal. These are just labels. Low fat diet or high fiber diet, whatever it is, these are just labels. Diet type. Pain level has to be ordinal. We have discussed any kind of level is always ordinal. Weight, just like height, weight is also ratio. So I'll skip that. Passport number and Aadhaar number. Passport number and Aadhaar number. Anyone?
Nominal, sir.
Why nominal?
Because we can define
So passport number and Aadhaar number are nominal. Answer is correct because though there are some numbers and alphabets which are present, and that numbers and alphabets has some meaning, but still, if, because my passport number is 1 and someone else passport number is 2, that doesn't mean I'll get first preference if I go for ticket booking. So these are just labels for me. Yes, these passport numbers and other numbers have some meaning for governmental bodies. That is fine. But for me, for normal public, passport numbers and other numbers are just labels. So these are nominal variables. Okay. Hair color. We have discussed this. Hair color is nominal. So this is the answer which we have discussed. You can cross check your answers. Okay. So now we'll go ahead. If I ask you a question, what is your level of understanding after some induction program or after some course, and if my sample size is 100, now you can understand everything what I'm talking about. I'm talking about a question, I'm talking about a sample size, I'm giving you 4 options. Looking at the options, you can say that this is a nominal variable. I am already expert on this is my first option. I remember quite a bit about this is my second option. Third option is I can remember a little bit. Fourth option is what are we talking about right now? That means I have not understood anything. So there is some order also. I can say it is ordinal. So be it nominal or ordinal, there is no numerical significance. What I have is only labels, only text, and that is my actual input, quality input or quality data. So whenever I'm talking about nominal or ordinal, I'm talking about quality of data. And what max I can do with nominal ordinal is I can count how many have said 1, how many have said 2, and so on. And if the count is available to me, from that count, what max I can do is I can draw the bar graph or pie charts. So from tomorrow, we are starting with Excel also. In today's session, we are not having any Excel session. So from tomorrow, we'll start Excel also. And first thing is we are going to start with data representation. So we are going to draw this bar graph, pie charts, histograms, or give curves and everything else in Excel in tomorrow's session. So if the count is available, what max I can do is I can draw the bar graph or the pie chart. So some kind of description and some kind of display is available. If I'm talking about nominal and ordinal, indirectly what I'm talking about is quality of data or qualitative data. Original data about service quality of a telecom operator. Sample size is 200. So suppose if you are using Geo, and if I ask you service quality of Geo as telecom operator, you may answer excellent or good or average or poor. So I'm representing excellent by E, good by G, average by A, and P by poor. So the first person says service is excellent, second says average, third says average, and so on. So I'm noting down all 200 data points. So this is my actual data, real data. This is my quality data. I'm talking about qualitative data. And now I can call this as maybe ordinal again, because I'm going from excellent to poor, positive to negative. So I can call this as ordinal again. And what max I can do if the count is available, that out of this 200, I have to count how many E's are present, how many A's are present. That means I can go for a frequency distribution table. Frequency distribution table. What is the meaning of frequency? Frequency means number of repetitions. Frequency is number of repetitions. So excellent is repeated 40 times, means excellent is present for 40 times. Good is present for 70 times, average 60 times, and poor is 30 times. The total is 200. So this becomes my frequency distribution table. If this frequency distribution table is available with me, I can draw again a bar chart or a pie chart to show it graphically. Okay. So in all these kind of examples, I have taken only these 2 examples. What we are dealing with is we are talking about quality data. There is no numeric significance to the data, like level of understanding, service quality of operator. And generally we are talking about nominal and ordinal types of variables, or nominal scale or ordinal scales. And this is nothing but your qualitative data. This is nothing but your qualitative data. Now the second category, if we have data values with some numerical significance, like consider age values of managers from nationalized banks. So I'm visiting the first nationalized bank, and age of the manager of that branch manager of that bank is 42 years. So I'll mention 42. Then second is 53, third is 52, and so on. So how many observations I have? I have 1, 2, 3, 4, 5, 6, 10 into 5, 50 observations. So I have visited 50 nationalized banks, and I have recorded the age of branch managers of these 50 banks. Every value is significant. Every value is significant. Every number tells me something. So there is a numerical significance to all these values. So these are just not labels. I can do addition, subtraction, multiplication, division, everything. So what I'm trying to understand is quantity of data, quantitative data. So in this example, I'm trying to understand quantitative nature of the data. Okay. So what I can do is I can draw a histogram, I can draw Ogilvy curve. This is called as Ogilvy curve. We are going to see how to draw Ogilvy curve using Excel also. Box plots and different data visualization methods are available for quantitative data. So this is when we are talking about quantifiable data. Every number is significant, like age, height, temperature. What we are dealing with is interval scale or ratio scale, and we are talking about quantitative data. So we have these two types of data which we can handle in any kind of analysis: qualitative data and quantitative data. So qualitative data deals with descriptions, whereas quantitative data deals with numbers. Qualitative data can be observed but not measured, so counting is possible. That's why it is nominal and ordinal only. And quantitative data can be measured also, so ratio and interval. Examples: smell, taste, appearance, happiness, pen level, understanding level, and all these things comes under qualitative, whereas height, weight, humidity, sound level, speed, all this comes under quantitative. So generally, when I say qualitative, we are dealing with nominal and ordinal scale of data types, and quantitative deals with interval and scale, interval and ratio type of data types. So the same example I have given here, data can be of two types: either it can be qualitative in nature or it can be quantitative in nature. So when I say qualitative, I drink coffee every day, it's a plain statement just to tell what I like. So I like coffee, so I drink coffee every day. But then if I specifically mention I drink 4 cups of coffee, then I'm counting number of cups. It becomes a discrete quantitative. It becomes a discrete quantitative. And then if I go into more details and if I try to tell how much sugar I consume with each cup of coffee, then I'm going for continuous quantitative. Then I'm going for continuous quantitative data. So data can be either qualitative in nature or discrete quantitative or continuous quantitative in nature. Every object will have some qualitative characteristics and some quantitative characteristics. It is not like the object can only have qualitative or some objects can only have quantitative. Like for example, consider this oil painting. This oil painting, if I am trying to understand what kind of color, blue color shade, green color shade is there, or gold frame is there, or frame is there or not there, what is the texture of the brush strokes, what kind of scene it is it a pleasant scene? What I'm talking about is qualitative data. But for same oil painting, if I'm talking about what is the size of the frame, what is the weight of the frame, then what is the surface area, what is the cost, then I'm talking about quantitative characteristics of the same object, oil painting. So it depends on what type of problem you're trying to solve, what kind of analysis you want to do. You are free to select either qualitative parameters of that object or quantitative parameters of that object. So as we have discussed, discrete data is counted and continuous data is measured, and that's why if you try to represent graphically the discrete data, you can draw the bar graphs. So if you can look at x-axis, we have doctor as a different bar with some height equal to 5, levels 5. Bus driver has a different bar and teacher has a different bar. There is no overlapping or there is no continuity on x-axis. But if you look at the second graph, frequency count of hours worked per week. So continuous data is measured. You can look at x-axis. All the bars are connected to each other and the x-axis is continuous in nature. For every value of x, there is some value of y. For every value of x, there is some value of y. That is not true in case of bar graph. So if you try to plot graphs or if you try to represent graphically the nominal and ordinal variables, you have to draw bar graph and pie charts. And if you want to, if you try to graphically represent the continuous variables, you can draw the histograms. Okay, so both these things we are going to draw using Excel in tomorrow's session. Discrete data can only take certain values and there is no gray area in between, numeric, non-numeric. It is possible for both. The number of students in a class, for example, has to be discrete in nature. I cannot have half student or 9.5 students. I can have only whole numbers. So discrete data can only take certain values. The result of rolling 2 dice, I can only have the values like 2, 3, 4 up to 12. I cannot have 5.6 or 5.5, 10.9. These kind of values are not possible if I am rolling 2 dice. So these are discrete in nature. When I say continuous data can take any value within a range. Person's height, it could be any value and not just a fixed to certain whole numbers. My height can be in fractions also. So time completion time in a race, in a marathon, you could even measure it to a fraction of seconds. So all these are continuous in nature. Temperatures are continuous in nature. Gender is discrete in nature. So this is what we have discussed. So once I say types of data, again to summarize, type data can be in, either in qualitative nature or quantitative nature. Quantitative data can either be discrete or continuous in nature, but qualitative has to be qualitative only. Or at the max, you can see it can be discrete. You can count it, so it can be discrete in nature. So based on all these types of data and everything, this is a common chart. This is a complete chart of data types in statistical analysis or measurement scales in statistical analysis. So data either can be quantitative or qualitative. Quantitative can be discrete or continuous in nature. And if it is quantitative, it has to be interval and ratio. Qualitative can be only discrete in nature. And as it is qualitative, it can be only nominal and ordinal. And in case of nominal and ordinal, if I have only two categories available, then it has to be dichotomous or non-dichotomous. Okay. So this is kind of one simple kind of summary of all data types in statistics. Can we go ahead? Yes, all of you?
Yes.
Okay.
Yes, sir.
So now I'll just give you some information about the time series data and everything. Though this is not part of this course, it's not a part of the course content, but just because we are dealing with all the basic concepts, you should be aware of what is time series at least. A time series is a set of data collected over time. Some examples of time series are stocks and share prices taken at regular intervals. So if I am following some stock price like L&T, for example. So what was the L&T share price on day 1, day 2, day 3, day 4, up to if I'm tracking that share from last 50 days. And then if I try to draw a graph of how the values are changing, that means I'm trying to do a time series analysis. Over the period of time, I'm trying to see how the change is happening according to time. That is time series analysis. Temperature reading taken at hourly intervals. So the example is given graphically also in this slide. So at 4, at 6, at 8, after every 2 hours, I am mentioning some temperature and I'm trying to plot that change temperature in a graphical manner. I'm doing some time series analysis. Number of cases of influenza in town on daily intervals, like what we are doing for Corona right now. From first, the day on first case came into picture in India till today, how the number of cases have increased, decreased. So I am doing a time series analysis. In time series analysis, we generally analyze the past behavior of a variable in order to predict its future behavior. And that is what is missing in case of Corona, that we don't have any past data available. So whatever data is available right now, based on that data only, we can do data modeling and we can do some predictions. And that's why it may go wrong also, because we don't have any past data to have a concrete or good prediction in case of Corona cases. So in case of time series analysis, you can do 2 different types of time series analysis. One is trend analysis and second is seasonal variation. Now when I say trend analysis, look at this graph. In this graph, sometimes the graph is going downwards, sometimes the graph is going upward, but the common trend is upward. The common trend is upward. So time series data may show continuous upward or downward movement with little fluctuation. Yes, fluctuation is there, but the common trend is, overall trend is upward. That is trend analysis. And seasonal variation. Seasonal variation means, look at this graph again. And this graph talks about maybe 7 years of data. In 7 years of data, maybe in every November and December, because just before start of new year, there is a spike. In every November, December, there is a spike. So this may be data about sale of woolen clothes, for example. In case of India, sale of woolen clothes, because November, December is winter time. The sale of woolen clothes have a spike in November and December. So that's the seasonal variation. So overall trend is upward. Overall trend is upward, but the seasonal variation shows me in details, further details about that upward trend. So this is a short-term fluctuation in a time series with which occurs periodically. That is seasonal variation. Okay, so either you can go for trend analysis or you can go for seasonal variation, and you can have both in one diagram also. So this one diagram can show you the upward trend as well as the seasonal variation. So you can have 2 graphs in between for describing trend analysis also and seasonal variation also.